Let's go to section number B. We are going to have question number 6 to 10 in section number B, and each of this question will be of 2 marks. So this will give you 10 marks in total. So let us do section B, next 5 questions. First question, now see with this diagram, before reading the question, we can make out that there will be some calculation involved. It will take some time, and if you know the basics, we can easily solve this. In the given figure, point charges are situated at the corners of an equilateral triangle of side 10 cm. Calculate the resultant force on the charge at B. What is its direction? 2 parts were involved. So actually examiner is seeking 2 parts in your answer. 1 mark he will give you to find out the value of the force on this charge, and 1 mark he will give you for the direction of that force. So let's go ahead with the solution. You can see here, we want to calculate the resultant force on the charge at B. So here we have to find out what is the force acting on this charge B and what is its direction. What is its direction? Let's go ahead. So what I'm going to do, I'm going to mark the direction along this diagram. You say C is minus 100 and Q here, B is having plus 100. Now here this minus 100 and this minus 100 is going to repel each other. So one force on B due to C will be towards right hand side. So I'm marking force on B due to C in this way. Now plus 100 and minus 100. Then we are going to have attractive force which will act in this way. Now each of the charges are given in microcoulomb, so you can make it out that this is given in microcoulomb. This force is attractive, this force is repulsive. Now let us try to find out, this is force on B due to A. Let's try to find out what is the value of each of these individual forces FBC and FBA. So force on B due to C, that will be nothing but you can easily make out by use the formula F is equal to K Q1 Q2 by R square. Let's substitute the values. So if we substitute the values, we are going to obtain the value of K is 9 to 10 power 9. With proper units, Q1 Q2, you see both are equal. So 100 into 100 will be having 10 to power 4 multiplied by, now see this is 10 to power minus 6 and 10 to power minus 6, we will be having 10 to power minus 12 divided by R square. Now this is 10 centimeter. If we do take it meters, it will be 0.1 or 10 to power minus 1. 10 to power minus 1 whole square, this will give us 10 to power minus 2. And with proper units, let's put up the units as Newton. So we got this. Now this was force on B due to C, which I have written here. This will come out to be, let me solve it here, it will come out to be 9. Force on B due to C will be equal to 9 with proper 10 to power, you see 10 to power 9, 10 to power 4. That will be 10 to power 13 minus 12, then 10 to power 1. 10 to power 1 and 10 to power minus 2 will go up, that will be 10 to power plus 2. So 10 to power 1 plus 10 to power plus 2 will be having 10 to power 3 Newton. Similarly, in the same way, if you see the diagram, we can evaluate force on B due to A. The values are same, 100 microcoulomb, 100 microcoulomb. The distance is same. The force on B due to A will be also same. So I am writing force on B due to A will come out to be same as 9 into 10 to power 3 Newton. Two equal vectors kept at 120 degree. Why 120 degree? Because it's an equilateral triangle. So this angle is very obvious, it will be 60 degree. So hence you can make out this will be 120 degree. Now if you remember, if you know the chapter on vectors, you have already learned that if two vectors are 120 degree, the resultant will be somewhere equal vectors. This will be the resultant direction, which I am marking here. The resultant will be directed somewhere here. Now what will the value of resultant? That easily you can make out. The resultant would be, just take the vector sum of both. So resultant F net will be equal to under root of F on B due to C whole square plus twice of FBC, FBA cos 120 degree. Easily we can solve this now. Now see, all these values are same. We are going to have the same value. FBC is also same, FBA is also same, FBC, all are same. So what we can do, we can write this as FBC. We can take FBC as common because all are equal in magnitude. We can write this as FBC whole square, and then 1 plus 1, 2 FBC whole square. So we will be having 2 plus 2 cos 120 degree. Let us substitute the values. What we are going to have? We can again take 2 as common, and FBC will come out. So FBC, and here we are going to have, take 2 as common, 1 plus cos 120 degree. 1 plus cos 120, cos 120 we can easily make out, that is cos pi minus 60, and that is equal to minus cos 60, that is equal to minus 1 by 2. So this can be written as 1 minus 1 by 2, or you can write this as 1 minus 1 by 2 will give you 1 by 2, 1 by 2 into 2, that will give you 1. Hence you are going to have this as equal to FBC. I am only writing the magnitude. So finally the magnitude will come out to be 9 into 10 to power 3 Newton. Now see, I have solved this completely, but if you have done the chapter on vectors, if you are remembering, if two vectors are kept at an angle of 120 degree, the resultant will be also of the same magnitude, and that we have obtained here. Now let's go with the direction. The first part, if you write this, the resultant answer as 9 to 10 power 3 Newton. So we are done with the first part. Now the answer of direction. This was 1/4, this was 1/4, both are of equal magnitude. This is the F net. So F net will be making an angle of 60 degree with this F on B due to C. Or how can you make the direction? How can you specify the direction? That would be, you can write the answer as, the net force would be making an angle of 60 degree with the line CB extended. So we're writing that net force makes an angle of 60 degree. Net force makes, and you can show in the diagram also, makes an angle of 60 degree with line CB extended. So if you extend this line CB, you have to make an angle 60 degree. This is the direction of the net force, which you can easily make out. Let's go ahead with the next question. Now we'll move to question number 7. You see here a battery of EMF 2 volt and internal resistance 0.1 ohm is being charged with a current of 5 ampere. Calculate the potential difference between terminals of the battery. Now see, this diagram will be somewhat like this. This is a battery which is charged. This is the internal resistance. Let's mark this end as A and this end B. Now its EMF is given as 2 volt and this internal resistance is given as 0.1 ohm. Now let me mark the sense of current. This would be going into the positive terminal of the cell, and this current is given as 5 ampere. Now since this battery is charged, the cell is charged, so that's why we have to mark the sense of current along this direction. You have to show this diagram in your exam answer sheet. So now let me write down the potential difference across terminals A and B. Here if you remember, normally generally where students get confused, they write VAB is equal to E minus IR. That is done when this was acting as a current source. This was acting as an energy source. But here during charging time, potential difference across A and B is given as E plus IR. Remember, I'm not using minus IR. That is when it is actually working as a current source, then we use minus. Here when it is charged, use plus sign. So if you don't know this, you are going to miss your 2 marks. But I know you are intelligent, you know this. So mark here E plus IR. Substitute the values. E will be 2 plus I value as 5. R value as 0.1. Now let me encircle this and mark the unit as volt. 2 plus 0.5 will give you 2.5 volts. This is the answer. the potential difference between the terminal of the battery. This will be the required answer for this, and you're going to gain 2 marks for this simple question if you know how to write down the potential difference when a battery is charged. Remember, only thing to note down in this question, if you remember in the current electrics chapter, when a cell is charged, use this simple formula V equals to E plus IR, and you are done. And if it is working as a current source, then you use V equals to E minus IR. Let's go with the next question. We have question number 8. Again, a question of 2 marks. Two uniformly charged spherical drops at potential V coalesce to form a large drop. If capacity of each smaller drop is C, then find capacity and potential of large drop. Now see here, we have 2 drops. Let's take its radius as small r. 2 drops of equal radius, because we are given that their capacitance is C. And if you remember in the chapter on capacitance, you know the formula for spherical capacitor, that is given as 4 pi epsilon naught r. This is given. Now they are going to coalesce and they are going to make one capacitor of one radius. So let us first try to relate both the radius of larger drop and smaller drop. If they coalesce, we are going to form one single large drop, which would be, which I am representing here, that would be like this. So just equate the volumes. We will be having total volume of these 2 spheres will be equal to volume of this sphere. So 2 into 4 by 3 pi r cube is equal to 4 by 3 pi capital R cube. From here you can see 4 by 3 pi, 4 by 3 pi will cancel out. We will be having capital R is equal to 2 to the power 1 by 3 into small r. We got one relation. Now you see here, they are uniformly charged spherical drops at potential V. So charge on each drop, let's evaluate the charge on each drop. Already we have this relation. I want you all to keep this relation with you all. Now if they are charged to a potential V, so charge on each drop will be nothing but equal to, use the formula Q equals to CV. So C into V, where C is equal to 4 pi epsilon naught R. You have to remember this. So Q is equal to 4 pi epsilon naught R into V. We got this. Let's say they are charged with a, it's given that they are charged to a potential difference V. Now see what is the requirement of the question. Coalesce to form a large drop if each capacity of each smaller drop is C. So C we have used here. Then find capacity and potential of larger drop. We have to find the capacity of larger drop. Q is equal to C into V. Capacitance of larger drop will be what? C of larger, or C nu, which I am marking as 4 pi epsilon naught capital R. Represent this capital R in terms of small r. This will be given as 4 pi epsilon naught, and capital R is equal to 2 to the power 1 by 3 into small r. See what we can write, 4 pi epsilon naught R is value of original C, that was capacitance of each of the earlier drop. So we will be having 2 to the power 1 by 3 C. This is the capacitance of larger drop. So this is the capacitance of larger drop, which I have written here, 2 to the power 1 by 3 C. Now we have to also find out potential of large drop. So let's go and find out potential of larger drop. Charge on large drop will be how much? Charge on larger drop. This will be nothing but Q plus Q, that is the charge of original drop, that will be equal to 2Q. This will be equal to 2 into C into V. V is used, I am using for the original small drops. C is the capacitance of original small drops. Now charge on larger drop we got as 2Q. Can we write this 2Q as equal to Q total on the present larger drop? Now we want to write the potential difference on this charge. So Q nu is nothing but C nu into potential difference nu. This is 2 into CV. We know that C nu is nothing but 2 to the power 1 by 3 into C. Now V nu is equal to 2 into CV. Easily C and C can be cancelled out. We will be having the new potential difference on the larger drop as 2 to the power 2 by 3 into V. This is the required result. See, two simple things have been asked in this question. First, what is the capacitance of larger drop in terms of the capacitance of the smaller drop? And we got that. That is equal to 2 to the power 1 by 3 into C. And potential difference of the larger drop, that would, when they are going to coalesce the smaller drops, then the potential difference that will be existing on the larger drop will be equal to 2 to the power 2 by 3 into potential difference on the smaller drop. Hence, we are done this. Easy question. Let's go to the next one. Question number 9. A capacitor has a capacitance of 50 picofarad, which increases to 175 picofarad with a dielectric material between its plates. What is the dielectric constant of the material? First of all, let me analyze this question easy. So sometimes in a 2 marks question, you may get a very easy question. If you attempt that, it will be a bonus marks for you. This is one among them. So let's go ahead. We know that C nu, whenever you are going to insert a dielectric between the plates of capacitor, this is equal to K times of C naught, where C naught is the original value of the capacitance. So K will be nothing but C nu divided by C naught. Now, what is C nu here? It is 175 picofarad. And what is C naught? That is 50 picofarad. So 175 divided by 50. Easily you can make out the value comes out to be 3.5. And K has got no unit mentioned in this way. And finally, after each question, also mention a line. The value of dielectric constant of the material is 3.5. You have to mention this line. So you are going to get perfect 2 marks for this question if you are going to completely describe the answer, and so that the examiner also becomes happy and actually is thinking that actually it's a formal way of representing the answer. So if you do that, you're going to attain full 2 marks for this question. Let's go ahead with the next one. Interesting question. The 10th one. Find the magnitude of magnetic moments of current carrying loop A, B, C, D, E, F, A. We have loop A, B, C, D, E, F, A. Each side of the loop is 10 centimeter long. So I'm writing each side of the loop to be 10 centimeter long. This is 10 centimeter. This is also 10 centimeter. This is also 10 centimeter. And so on. We have 10 centimeter each side of the loop, which I have marked here. And current in the loop is I 2 ampere. Current in each segment will be 2 ampere. Now we have to find out the net magnetic moment. First of all, I will like you all to recall the formula for magnetic moment that was given as M is equal to I into A. Now here, students get confused. Actually, this is not a planar loop because we are having this arrangement in 2-dimensional space, or let's say this is actually in a space. It would be shown to be in this way. Now, how to find the magnetic moment? You see here, imagine this part A, B, and let me connect this with dotted line A, B, E, F, A to actually make up a loop. So we have one loop, loop A, B, E, F, A. Complete this, we can easily find out the magnetic moment of this part. And you must be knowing that the magnetic moment is a vector quantity. Its direction is directed along some sense, and that sense you can evaluate by right hand rule. You have to actually take your right hand and curl the fingers, the first 4 fingers, along the sense of current. So if I curl it, I'll be having my thumb is going downward. So the magnetic moment will be directed along the downward direction due to A, B, E, F, A. If I curl it, I'll be getting magnetic moment directed in the downward direction. And let's say this is the value as equal to M. This will be equal to loop ABFA. I'm writing the magnetic moment as IA. Now I is how much? 2 ampere. And area you see each length is how much? 10 centimeter. That means 0.1 in meters multiplied by 0.1 again. So 0.1 into 0.01 multiplied by 2, 0.02. We are having ampere square meter. This is the value of magnetic moment of one of the loop that's formed due to A, B, E, F, A. Now see here, we have another loop B, C, D, E, B. So loop B, C B, C, D, E, B, if I make out that, think of loop B, C, D, E, B. Easily you can make out the magnetic moment in the same way as equal to I into A, and both values are same. So we are going to get 0.02 ampere meter square again. Now what is the sense of this magnetic moment? You see here, if you curl your fingers in this way, thumb is pointing into the plane of board, so we'll be having two vectors, one going into the plane of board and one directed downwards. This is vector number, let's say 1, and this is vector number 2. So the resultant of these two perpendicular magnetic moment will be done in vectorial form, and that's nothing. So net magnetic moment, I'm using this part to show you all here. The net magnetic moment is two vectors will come out to be, easily we know two equal vectors, and if they lie perpendicular to each other, it's given as root 2 m. So let me write here root 2 into 0.02 ampere meter square, or we can write this as 2 root 2 into 10 to the power minus 2 ampere meter square. Now this much is enough. If you want, you can further expand this. 2 into 1.414 into 10 to the power minus 2 with proper units. Remember to express units every time. Don't miss this unit, examiner may get a chance to deduct your marks. So that's why I'm mentioning the units every time. So 2 into 1.414, this will give us 2.82, nearly 2.82 into 10 to the power minus 2, or you can even leave your answer till here 2.8, because you can use this standard way to express an answer. So 2.8 into 10 to the power minus 2 ampere meter square. This is the required result, and again if you reach up till here, you are going to make your 2 marks positively. So this was all about section A and section B part of this paper. I will request you all to see the entire chapter of your syllabus of class 12th curriculum, so that you should be easily acquiring these 5 marks in section A and 10 marks in section B, which is an added advantage if you know the basic part in these. So easily you can get this 15 marks, you can secure this 15 marks. So after this part, I'll be continuing next class with section C and section D. Till the time, thank you for joining me and wish you all the very best for your board examination. Thank you everyone.